Guys, I drew out a little something here I wanted to discuss before we hop into the lab. We'll get into the lab in a minute. I wanted to discuss resistors in series and resistors in parallel. When resistors are in series, you add them. So let's say we wanted a 470 ohms resistor for our LED, but we didn't have a 470 ohms, but we did have 220 ohms. And in some cases, that may be close enough. So what we did was we put two 220 ohms resistors in series, and when they're in series you add them up. So our 9-volt battery goes through these 220 ohms resistors, and we'll actually do this in the lab, and this will measure out to be 440 ohms. We'll see it in the multimeter to our LED and then to ground. Now resistors in parallel, and this is a really bad looking resistor right here. In parallel, if these are two 1K resistors or 1,000 ohms resistors, it doesn't matter if they were 220 ohms resistors, then their total resistance reduces and it would be 110. But in this case, they're 1,000 each, so it would actually be 500 ohms in parallel. So you see here that, you know, if I didn't have a 470, I could use two 1Ks in parallel and have 500 ohms and the LED would light up. Now you can do other components in series and in parallel as well. Like for instance, LEDs in series. And any of you who have dealt with Christmas lights and one goes out and they all go out, well, those are in series. So if we break this, we break the circuit. Well, we could also have them in parallel. And that's what this is. These are in parallel, but I could actually have, so if one of them blows, the other one still continues to go. And of course, this is minus over here. Let me get some color. Minus on this side. Wrong. Huh. Okay. Negative on this side, negative on this side. And I don't have any resistors in here. We could put them in depending on the voltage. Like here, this is 3 volts. This would work perfectly fine. I could put 2 LEDs off of 3 volts without any resistance in parallel, and these would light up great. And if I use the same 3 volts here, these may not light up great. We're actually going to try this. Depending on the LED, it may not light at all, or one may light and the other one doesn't light. But anyways, I just thought I'd mention that briefly before we get into our lab, because we're actually going to do this in the lab, and instead of confusing you guys on the breadboard with it, I just wanted to draw it out. Okay, welcome back. We see a few more items on the table now that I have collected, and we're ready to begin. Actually, I should grab a couple more of these cables. Maybe we have enough. Okay, you can see here our, actually, we'll keep the testers on. We'll keep all this tester equipment on our multimeter. 9-volt battery, and okay, so we're on continuity. That's off. DC voltage is here. Basically, if you don't know what you're measuring, start at the lowest value and move your way up. I don't know if you can see this in the video, but it's reading something anyway, 0.5 volts, just from the air. It's actually set for 200 millivolts. Now, when I look at this 9-volt battery, I see the positive on the small end and the negative symbol on the larger end, so I know my positive and my negative. But I'm going to show you what happens when we test it backwards. That way you can test for polarity as well. Okay, so we're going to connect the positive to positive and the negative to negative, and on our 9-volt battery, and we get a 1 on our multimeter, which means it can only, we're set for 200 millivolts or below. Actually, I'm going to take these off temporarily, and we're going to clamp this on here. These clips, positive to positive, negative to negative, like so. And we got a 1, so let's move up to 2 volts. We still got a 1, which means it's higher than that. So we move up to 20 volts. and we see our battery. This is a rechargeable 9-volt battery, by the way. We see it reads, and hopefully you can see that, 9 volts, 9.01 volts. And it's going down. It's actually taking a little juice away from it, and if we kept it there, it would read a little lower as we went along. Okay, so we got now 9 volts. Now what happens if we reverse this? Say we didn't know what was positive and what was negative on this, and we did it in the reverse. Well, now it really reads negative 8.97 volts. So there's a little negative symbol there. So it tells you that we have this backwards. So for our correct polarity, we see now it's 8.99 volts. So our polarity is now correct on here. Okay, so we know which is positive and which is negative here. Shut off our multimeter. It's not an auto shut off. It will drain our battery. Very inexpensive multimeter. So now we have this cap, and of course in one of the tutorials, maybe 2 or 3, I actually put a list together of all the parts that you'll need, and you know, this was one of them, the battery cap that goes over the 9-volt battery, and the big side to the small, small to the big. Now we can test the battery this way with this on it as well. So let's go back to 20 volts. It'll measure 20 or below, red to red, black to black, and we see 8.98 volts. And if we reverse them, see, these clips are great, and these wires are great too. This is going to help with your building this stuff greatly. Okay, so and now we see the negative symbol. Hopefully you can see that there. There's a negative symbol there. If you don't, you'll be able to see it on your own multimeter, and you'll know that it's backwards. Okay. Now, what I said before in my tutorial is I try to push the positive. You know, if you look at this breadboard, you see there's a positive and a negative on this side, and a positive and a negative on the other side. And you can plug whatever you want into it. You don't have to plug positive and a positive. These are just connections. But what I try to do is I plug positive on one side, and then the negative on the other. So when I build my circuit, my flow goes from one side to the other. And I don't accidentally, these are too close together, I don't accidentally plug in the wrong one. So let me take, and we don't have power protection yet, so we got to make sure we put these parts in right. We haven't had the diode tutorial yet, so let me see if I can zoom in on this a little bit. There we go. Okay, so let's take the positive, and this wasn't mentioned in the tools list. It's like a little dental tool. You can get these at electronic shops or online. Sometimes these boards are hard to push things in, and with these battery clips, the ends on these battery clips can be very difficult to push in. I actually soldered these ends, tinned them, so that they'd be easier to push in, but even then it can be a little trouble. So if it gives me a hard time, I can use this to help me push that in. Just like that. Positive to positive, and then over here, let's keep this in view, negative to the negative side. There we go. That's in there. Maybe not as sturdy as I'd like, but it's in there. Okay, now let's take our probes and add these wires again. Like I showed you before, these wires here. Come on, focus, focus. It doesn't want to focus. And we put that on the clip. And we put that on the black clip. This is our first lab. Our labs will get a lot more elaborate than this. Let's zoom out so we can see the multimeter. And let's go, we're still on 20 volts. We didn't shut it off. Now, if I put the negative into the positive rail, and the positive into the negative rail over here, we read a negative 8.97 volts. Let's put it in the other way, and we read anywhere on the positive rail, anywhere on the negative rail, positive 8.96 volts. And I can put it down here, but once again, if I put it into this negative rail here, even if it's in the negative rail here, we get no reading on the multimeter. 0. So if I plug these in here, we get 0. 0. So right now, the power is only going to these rails right here. The positive on this rail, the negative on this rail. Okay, now we come to the resistors. I got some resistors here, and I pre-labeled them, but you know, let's turn them over so that you can't. Well, you can see 1K on that, and so we got them turned over. Now I'm looking for a 470 ohms resistor. Now you heard me counting. Now you get to see me counting. You heard me counting before to figure out the colors that I need. Okay, remember we go from dark to light, and we follow the rainbow. So black is 0, black is 0, brown is 1, red, orange, yellow. So we want a 470 ohms resistor. So actually, let's do it this way. Black, brown, red, orange, yellow. So we want, for 4, we want yellow. So our first band should be yellow. Our second band, we want 470. So the second band is our second number, which is black, brown, red, orange, yellow, green, need that other hand, blue, violet. So yellow, violet is 4-7, and then we need 1, 0. So it's not like yellow, violet, black for 0. No, it's, remember, the third band is the multiplier, so we want 1, 0 there. So it's 0, which is black, and then brown. So it's yellow, violet, brown. So if I look at this here, I see brown, brown, yellow, violet, brown. And if I turn it over, there's my 470. So this is my 470 ohms resistor. Now, but the thing is let's say I didn't know that, and let's say I need to be more accurate than 470 ohms. I need to know exactly what this resistor has. So let's take this resistor out. And once again, sorry, I didn't zoom in on these colors, but we need to see the multimeter for this portion of the tutorial. Okay, let's take these wires out of the alligator clips. We'll just use the alligator clips. Now, when you're measuring the ohms value of a resistor, and just to reiterate, or as a reminder, the higher the value, the more electricity it resists, the less electricity they can get through it. So we're looking for a 470 ohms resistor. If you remember from our math, that's what we determined we needed for an LED light. So when you're measuring the resistance of a resistor with the multimeter, don't hold on to both ends because it can affect the readings. Okay, so let's look closely at our multimeter. I'd like to turn it this way, but then you guys will be seeing it wrong. Okay, so what we have here for measuring ohms is this green right here. We have 200 ohms, 2K ohms, 20K, 200K, 2 million that we can measure ohms with. And remember, if you don't know what it is, I mean, we know this is a 470 ohms resistor, so we go to 2K, because that'll measure 2K. That'll measure 2K and below. 200 will measure 200 and below. But let's assume we don't. Let's just say we took it out of our parts bin and we want to see what it is. So we come down here, and what I can do is, if you don't have these clips, you can measure it this way. Okay, let's take this resistor, and in one hand I hold it. See, I'm holding that in one hand, and then in the other hand I touch the other probe to it without touching it, and we got a 1. Let's bring it up to 2K. So it says 4. It's jumping a little. It's because I'm moving around here, and so 465. It's a 470 ohms resistor, and it's got a gold band, so it's 5% tolerance. If you remember our plus and minus tolerance, we do that. But I like the alligator clips because we can get real accurate with that and avoid. Let's actually touch it with both hands and see what happens. So now we get still the same thing, 465. And if, you know, there was a little sweat on my hands, that's how some of the basic lie detectors are done. They measure the resistance in your hand through the sweat. And we'll actually measure the resistance in our hand in a minute. But right now, so that's 466, 465, and without my other hand touching, it's 465. But so you should only touch one side. Don't touch both sides. Okay, let's go to the clips. Red, the alligator clips, and black. This is going to be a long lab, by the way, guys. We got a lot to do, which is good. Okay, so now we have our clips, and it doesn't matter. These resistors have no polarity. It doesn't matter which way you put them into your circuit, which side's positive and which side's negative. It doesn't matter. So let's go back to 200, and we see that that is a 1, which means we need to kick it up. So we kick it up to 2K, and we see that the resistor reads, without me touching it, 466 ohms. So this is our 470 ohms resistor with a 5% tolerance, and this one is exactly 466 ohms. So that's one 470 ohms resistor. Okay, now what we're going to do is I'm going to zoom in for this part. Let me grab an LED from our parts bin. Okay, here's our LED from our parts bin, and we'll zoom in on this. Okay. We'll shut off our multimeter so we don't kill that battery. At the end of this tutorial, I actually changed the battery in this multimeter, and you'll get to see how. I'm going to add that video at the end of this. Okay, let me zoom in. Maybe zoom out just a tad, right about there. Okay, so now we're going to go from our positive rail. Remember the positive rail here. So we're actually connected to the power. We're connected to the positive rail. And we're going to go into having a little trouble getting that part in. It's a brand new breadboard. Those are the worst to deal with. You can just try another hole if one's too tight. So basically our resistor is going from the power on one end to one of these rails. It's actually rail 10. It's rail 10, port J. So if I look across, it's 10. I look up the top, we have A, B, C, D, E, F, G, H, I, J. So it's going into 10J. So now we have our LED. This is a funky LED I grabbed. It's actually got a flat top on it. And remember, the LEDs have polarity. So let's zoom in on this LED a little more. And come on. Oh, don't want to focus on that. Okay. Well, we have one leg that's longer than the other. Okay, the long leg is the positive, short leg goes to negative. So I'm going to refer to the flow of electricity going from positive to negative. So don't worry, I know it goes, we discussed how it goes from negative to positive. But, so we take our positive end and put it on the positive side. See, here's the power. Here's our resistor. And we plug the positive end on this side of the resistor. And then the negative end is going towards our negative. Now, we still don't have a light yet. It's still not lit up. And, of course, because it's not connected to ground, so it hasn't completed the circuit. So the short end is over here. It's also the flat end. And so now we need another wire. It doesn't matter what color. I'll use black just so you guys will think of it as negative. And we plug it into here and then into our ground. And our light does not light up. Okay, let me grab another LED. 90% of the time, and this is, I like to keep the labs real, we will run into problems, and we will troubleshoot these problems, and you can watch us troubleshoot these problems, and it'll help you as well. 90% of the time, it is not the component. 90% of the time, it is, quite frankly, me. Anytime I make a mistake on these boards, it's usually not the component. It's not the integrated circuit or the component I'm using with. It's not a bad resistor. These LEDs are actually crap LEDs, so I'm actually going to go test this LED. And yes, it was the LED. What I did was I took a 3 volt to test it. This is a different LED. I took a 3 volt battery without any resistance, and I put the positive side and the negative side, and now I have a working LED. So in this case, it actually was the component, and of course we're doing a video, so okay, so now we'll take this component, and the long end goes into the positive side, and the short end goes over to the negative side, and of course we have light. It lights up. And if we break the circuit, the light goes out. And if we connect the circuit, the light goes on. So that's our LED light. Now, remember in the video I told you it doesn't matter where you put the LED, whether the resistor is before or after the LED. So let's test that theory. So we take out the LED, we'll take out the resistor, and let's put, remember, the long end on the positive side into positive, the short end heading towards negative. Now we're going from positive to negative here, and then now we take our resistor and we put it in this row here, and then we plug it into the row over here, and we light up. And it's still offering the same protection. It's still offering the same protection as if it was before it. So, and actually we can see what's going on here. This should have been for a later tutorial, but let's take a quick look at this anyway. Let me zoom out so you see our multimeter. And let's put our multimeter to 20 volts. Let's take our probes. We have a black and a red, and sorry, I'm out of black wires, so I'm going to use the next best thing, which is a blue. So we have 20 volts. Now if we put it into positive and put it into negative, we see across our entire circuit we have 8.8 volts it's reading. But if we put it on one side of the LED and then on the other side of the LED, it's reading 1.93 volts. And I'm going to zoom in on that so you can actually see where the connection is. You see one side of the probe is on one side of the LED, the other side of the probe is on the other side of the LED, and it's reading 1.93 volts, and that's what that LED is using. Now we come across the resistor, so one side on one side of the LED, and we're going to actually, I'll show you these test points again in lecture so you'll see it, and one on the other side of the resistor, and we see 6.93 volts. And if we add these up, we should get what our total voltage was. So we see that the resistor is actually taking on 6.93 volts for us and helping us run our LED. Okay.